Right, like I said today, so we're going to be walking through some setup configuration and features within NeuralSeek within an AWS environment. We're going to be following our AWS Learning Lab guide, and that can be found at labs.neuralseek.com. And as a note, today you won't need to be bringing an Amazon Kendra instance with you. We already have one provisioned for us today and did a web scrape of our documentation prior to the lab. To effectively configure it with a knowledge base and a virtual agent within an AWS environment. In Module 2, we'll be looking at seeking answers, and that will be highlighting some key features of NeuralSeek that are instrumental in training virtual agents. And then within Module 3, finally, we'll be exploring Maestro feature, where we'll be just scraping the surface of some of NeuralSeek's dynamic playground for free-form content generation, task automation, and leading RAG for enterprise. All right, so let's get started then. I'm going to launch Module 1.1 of my Learning Lab guide and log into my AWS console, which I have pulled up here. So our first step is to get NeuralSeek provisioned. So I'm within my AWS console in the AWS Marketplace, and you can go a few ways to search for the products, either within the search bar here or through this Discover Products link on the sidebar. I have our instance right down here within NeuralSeek. So there will be two different products for NeuralSeek that will pop up. If you do not have access to your own large language model, we're going to be using this NeuralSeek by Cerebral Blue instance, which does use our provided curated LLM included. So we'll be going with this option for the lab. But if you did come prepared with your own large language model and the necessary keys and region, then you are feel free to choose the NeuralSeek Bring Your Own Large Language Model plan. So after I select our product from the list, I'm going to click Set Up Product at the bottom. And it'll show us the offer that we've subscribed to. And after reviewing that information, I'm going to go ahead and click Set Up Your Account in the top corner. Awesome. Okay, so please note that these NeuralSeek subscriptions, when they are created, will incur billing and cost as they are used. So when running through lab verbatim, the cost came out to be about $1 or so, but note that that price might increase if you end up playing around a bit more in the instance after the lab. And at the end of our lab, we do have steps to deprovision these instances as to not incur further costs. All right, so we've set up our account, and this brings us to our NeuralSeek instance control page. And on this page is where we'll be able to create a user and create an instance of NeuralSeek in order to access it. As you can see, we have quite a few users and instances already. Yours might be blank. Up here, we have two different boxes. We have our add a user, where I can input an email and create my user. And then I have our instance, which we will also create as well. But I'm going to start with the user. So in the add user box, I'm going to input my email and then click the blue icon right next to it. Perfect. And that will populate my new user down below. Here we can see jfrance@techd.com, and the password that is generated with it is unique. So I'm going to copy that because I'll need to save it for later. But there is a forget password link on the login page of the instance where you're able to change this to a more memorable password for yourself. I'm going to copy that to make sure I have it. And now I have my user configured and I need my new NeuralSeek instance configured. So I'm going to click under Create Instance. I want to make sure I'm in our correct region of US West 2, and I'm going to click the blue plus icon, and a new instance is generated. And it comes with a pretty tricky instance ID here, so I'm just going to find that down below. Right here is our new instance, and It has a few different options available next to it. You're able to delete, but I'm going to change the name of our instance just by clicking this writing tool icon to something more memorable for better ease of navigation. I'm going to name this NeuralSeek Learning Lab. And I'm going to provide today's date as well. All right, I'm going to click that writing tool icon to save our new name. And we can see that populated down here below. So now we have a user and we have an instance, but there is no connection between the two yet. We can see that here as our user has access to 0 instances and our new instance has 0 users. So there's 2 different ways you can go about connecting this, either clicking the plus icon to configure user access to an instance, or vice versa, configure user access to this instance by clicking the plus icon next to the instance name. I'm just going to go with that route. Perfect. So we want to configure users. We want to make sure that we're on our correct NeuralSeek instance. And then I'm just going to select my name to add that user to that instance. Perfect. So I'm going to close out of this. And just to confirm, our new user, my email address, now has access to 1 instance, and our new NeuralSeek instance has 1 user. So we have established that connection. Our next step is to actually access NeuralSeek's user interface, and you simply click on the name of the instance in order to do that. So I'm going to click right there, and it pops up our NeuralSeek UI. And this brings us to module 1.2 of our Learning Lab guide, which will be walking us through the home journey within NeuralSeek. So now that we're on the UI page, we want to start with adding a company name. So the knowledge base that we're going to connect to is set up with our NeuralSeek documentation. And the company name is important because we use it to focus user questions based on our corporate data. And since our data is NeuralSeek, we're going to name our organization NeuralSeek for best results for the lab. Our next 2 options here, we can pick a default language. I'm going to stick with English. It's best practice to match the language of our knowledge base and our user questions, but NeuralSeek is able to translate between many languages. And then this last selection down here is we're going to select a use case for our NeuralSeek instance. So we're basically asking you, is this instance going to be used internally within your organization, or is it more external and customer facing? And we take this information to pre-tune some safety parameters for you. But in this example, we're going to stick with internal because we do not need some of the extra guardrails implemented just for our testing purposes. And to save our inputs, we'll just click next. Perfect. So this brings us to our data screen, which is where we'll connect our knowledge base. And we need to select our knowledge base type. And today it will be our Kendra knowledge base. So I'm going to scroll down in our drop-down menu until I find Kendra. And then I'm going to leave our knowledge base language as English because that's what our corporate documentation is written in. And these next few inputs that we need here are index ID, our role access key, our secret access key, and our AWS region was sent in an email prior to the lab connected to the PowerPoint here. So I will display those on the screen. So these are the parameters that we're going to need to input into our NeuralSeek instance. So I'm just going to take a moment and copy that over. Our AWS region is US West 2. Our Kendra index ID, I'm going to input in here, along with our access key and then our secret access key. Our lab guide does include information on how to generate these access keys and where to find them within a Kendra knowledge base as well. All right, so before I click next and move on, I want to test our connection, and we're looking for that green check mark saying that our Kendra response time is successful and configured. Perfect, so I'm going to go ahead and click next to move on to our next screen, which is organize. So in this top category here, we're not going to be utilizing much of it for the portion of this lab, but just for your reference, you can do automatic intent categorization just by describing a category with natural language, and then we work to automatically organize user questions into those categories. On this screen, though, we will be defining our virtual agent platform. So from the drop-down menu for virtual agent type, I'm going to select AWS Lex V2 as that's the virtual agent we'll be creating. And then I'm just going to leave embedded links into returned responses disabled as it's just unnecessary for the purpose of the lab, but it is an option available. I'm going to click Next to save our input. And this brings us to our tuning screen, which allows us to tune NeuralSeek for our data. So our first question here is asking us which one of these blocks looks most like our data. And it's best to match the data in our source. So I'm going to select the larger text block because that best matches what our corporate data looks like. Important phrases surrounded by many lines of text that explain them. But depending on your own corporate data, you might want to choose the smaller block if you have more focused data. An example of this would be FAQs. The second option is I'm going to describe our data requirements, and I'm going to leave this as the default of wanting to give the LLM lots of information and then giving it that leeway to decide the answer. We are able to limit how many documents are sent to the LLM, but just for the purpose of this lab, we'll stick with that top option. And then finally, we'll stick with all of our documents are current and relevant to describe our data currency because our documentation that is uploaded is up to date. The other option describes data sources that might be outdated or have some irrelevant information. And this could be useful if you had information such as blog posts, and selecting that option will allow NeuralSeek to know to deprioritize those outdated data sources for better answer generation. I'm happy with these answers. I want to save them, so I'm going to go ahead and click Next. And this brings us to our landing page of Welcome to NeuralSeek. So at this point, NeuralSeek is ready to begin seeking. And these features here take some time to process, so I'm not going to delve too deep into them, but I will go over a little bit for your reference. So auto-generate questions here. When I click that, it will help you to bootstrap your project. It generates a list of questions that users are predicted to ask about our knowledge base, and then we can just upload that and submit them and drop them directly into our Curate tab. Going back, in a similar fashion, we have manually input questions and uploading test questions. So you can manually input a list similar to the auto-generate, or you can upload a set of test questions. This link provides a CSV template for you to download, and it's very helpful if you have subject matter expert testing sorts of questions to upload into NeuralSeek. But just to summarize, we have set up and launched our NeuralSeek and configured it with a knowledge base of AWS Kendra, and we're ready to begin searching. This moves us on to module 1.3 of our Learning Lab guide. So I'm going to pull that up here. And at this point, we're going to learn to connect our AWS Lex virtual agent. Right. Perfect. I have that pulled up. So staying here in the NeuralSeek UI for a moment, I'm going to navigate to the Integrate tab at the top. Here we have a couple different options. The one that I'm looking for is Lex V2 Lambda. So I'm going to select that. And then we need to be able to get this function over to AWS so that way we can enable fallback search. It does provide a list of steps for you to follow, and I will walk through those here today as well. Down at the bottom is a button that you can click to download a zip file, the Lambda archive zip file. And so this is what we're going to need to bring over into our AWS console. So I'm going to go ahead and click that to download it to my local machine. Perfect. So now, great, I have that downloaded. And now we'll need to navigate back to AWS. And we want to find the Lambda functions page. We can do this easily by clicking on step 1, open the function page here, and it brings us directly into our AWS console. Another way you could do it is navigating back into AWS Marketplace console and searching for Lambda function in the search bar. So I'm going to let that load for just a moment. Great. All right, so now I'm on the AWS Lambda functions page, and we're going to create a new function. So I'm going to click the orange create a function button here at the top. Awesome. So I'm going to leave the options selected for authoring this function from scratch, and then just follow some of the settings down below. So the first thing I'm going to do here is provide a unique name for my function. I'm going to provide it very similarly for ease of navigation. So I'm just going to do NeuralSeek Learning Lab. I'm going to add today's date for ease of reference. The runtime information I'm going to leave as the default along with the architecture, and permissions and then any of the advanced settings are also fine as the default. So I'm just going to scroll down and select create a function. Great, so we've successfully created our new function here. And scrolling down just a little bit, we're going to see our function load in our code source pane. And this is where we're going to upload that Lambda archive zip file that we just downloaded from our NeuralSeek instance. And I can do this by selecting upload from zip file. Yep, that is fine. I'm going to upload, and then it's going to open up my file explorer where I'm going to select that Lambda zip file and then click save to go ahead and upload that into our code source pane. Perfect. So it's updating and successfully updated our function here, and I can see that down below. We are going to make a few adjustments in this section, and the first one that we're going to make is right here in line number 3 and 4. We have our NeuralSeek URL and our API key. I need to enter these here within the quotation marks. Both of these are found back within our NeuralSeek Integrate tab. Right here under Lex V2 Lambda, where we just were on step number 7, and we're able to copy both our API key and our instance URL. Bring that over into our Lambda function, and I'm going to paste that right in here where it directs me to. Starting with our URL. And then I'm also going to paste in that API key. There's one more edit I need to make on this page, and that'll be down here on line 16 in the messages array. And I'm looking at the content type saying custom payload. So we're going to delete this content type in the messages array. And the reason that we're doing that is because this function will allow the virtual agent to respond with some JSON, and that shows like our different parameters. And that message content just doesn't need to be displayed in our virtual agent. So I'm going to go ahead and delete it, starting from the comma mark all the way to the curly bracket. And I'm going to leave that square bracket there. Great. Finally, at the top of this code source pane, I'm going to click deploy just to make sure that our changes are saving. And then we should see a green bar at the top confirming our successfully updated function. And we're going to stay on this page just for one more moment. At the top here, we can see code, tests, monitor, configuration tab is what I'm looking for. So this is our general configuration tab, and the one edit that I'm looking to make here is our timeout settings. Currently it is set at 3 seconds, which is a very short default timeout setting. And so we're just going to want to adjust that before moving on. I'm going to click that edit button off to the right and leave all the rest of the settings fine, but just under here, under timeout, I'm going to set that to 1 minute and 0 seconds just to ensure the Lambda function does not time out for 1 minute. Then I'm going to click Save at the bottom. Okay, So now we have successfully set up our Lambda function for our fallback search. And our next step is to create our Lex bot. So staying within our AWS console, at the search bar at the very top, I'm going to search for Amazon Lex. I'm going to search that service right there and give it one moment to load. Within this Lex console is where we're going to create our new Lex bot. Great. If you do, I'm just going to click the orange Create Bot button here in the top right corner to create a new bot. Our creation method, we have a few different options that are available. I'm going to select Create a Blank Bot. And then we're just going to follow some of the guidelines down below. So our first step that we're going to do is we're going to name our test bot. So I'm going to name this NeuralSeek Learning Lab. Amazing. Optionally, you're able to add a description for your bot configuration, but I'm going to skip that step. For our IAM permissions, our runtime role, I'm going to choose create a role with basic Amazon Lex permissions. For the Children's Online Privacy Act, I'm going to select no. And then our idle session timeout, as well as any of our advanced options, are good as default. So I'm going to go ahead and click next. Same as before, our selected language is English as our default, and that is satisfactory to me, along with the voice interaction steps. So I'm going to go ahead and click Done to set and create our bot. Great. So we see that green bar at the top saying that we've successfully created our new Lex bot. And now we're looking at our intents. So here we see a new intent was created along with our fallback intent. And we need to add at least one intent into the Lex bot. So staying within our new intent, I'm going to scroll down a little bit until I find the sample utterances screen. And down here, I'm going to add an example utterance. It can be anything of your choosing. I'm going to go with something simple, such as hello, and then click add that utterance. And then to that, I would like to include an initial response. So directly below the sample utterances is our initial response screen. And I'm going to expand that caret. And under the message, I'm going to say, welcome to the test spot. You can fill this in with anything of your choosing as well. And I'm going to go ahead and save that intent. Great. So our next step here will be to select a language. So going back to our intents list, I can navigate to that by selecting this blue arrow on our sidebar menu back to intents list. And then where we're going to look to select our language is I'm going to be under deployment and then aliases. And that's found right here on the sidebar. So I'm going to go ahead and select aliases. And that brings up our test bot alias. And I want to navigate inside of this. So I'm going to click on the name. And that will bring me inside the test bot alias. And this is where I'm going to look for languages right here. I'm going to select the English language to navigate inside of it. And this is where we're going to set up that Lambda function. Under our source from the drop-down menu, I'm going to search for our new Lambda function that we just created, NeuralSeek Learning Lab, May 2nd. And it will auto-populate our Lambda function version as latest, and that's what we would like as our default. So I'm going to go ahead and click Save since this is satisfactory. Great, so now our language settings have been successfully updated. And now that they are updated, we can start hooking up our LexBot to our fallback intent. And this is done back on our intents pages. So from the sidebar menu, I'm going to go to bots or different versions under our selected English language intents. And then here we have that new intent that we just created as well as our fallback intent. So I'm going to click the name of the fallback intent to navigate inside of it. I'm going to scroll down a little bit here until I find the fulfillment section, and this is what we're going to want to set to active. So expanding the caret here and then choosing the advanced options, what I'm looking for is our fulfillment Lambda code hook, and I want to enable this by checking it to use that Lambda function for fulfillment. So I'm going to go ahead and update those options after I've checked that box, and then I'm going to go ahead and save that intent. And you can see that it is switched here. Our fulfillment is now turned on to active. So scrolling back up to the top, in the top right corner here, we have two buttons, build and test. I'm going to click build in order to build our Lexbot. And it does take a moment, so I'm just going to pause for that. And when a green bar appears, it will confirm our successfully built bot. Perfect. So there's that green bot. Our successfully built bot under our selected language is ready to use. And we can go ahead and test this using that test button. And it brings up a model of our chat bot. And within the message array, I'm just going to take a moment and ask a question that I know would be in our knowledge base just to ensure that that Lambda function is being triggered. So I'm going to go with what is NeuralSeek? Great. So we see those three dots right there showing that it has triggered that Lambda function, reaching out to NeuralSeek's API and performing that fallback search and providing us a natural language response here from our documentation about what NeuralSeek is. Great, so that looks good. So just to recap, we are finished with Module 1, configuration and integration. We have successfully set up NeuralSeek, configured it with a knowledge base, and we've also set up a functional AWS Lexbot with that Lambda fallback function. Great, so I'm going to X out of that. And I can pause here for a moment if you would like to ask a few more questions to the bot to play around in that test chat. While I load up Module 2 of our Learning Lab guide. Okay, great. So we've completed setup, and now we're going to take a deeper dive into NeuralSeek itself. I'm going to navigate back to our NeuralSeek UI page. And the purpose of Module 2, Seeking Answers, is to highlight some key features within NeuralSeek that are instrumental in training our virtual agents. So Module 2.1 of our lab guide, it navigates us over to our Seek tab. So I'm going to go ahead and click Seek. And this is the page where we can go ahead and ask any of those user questions, and we'll start to see another level of detail and depth to our responses, more than just what a chatbot would give. This instills some accuracy or ensures accuracy and instills some more confidence in the reliability of the responses that are being generated by NeuralSeek. So we'll start with asking something that we know is not in our knowledge base, like what is the best cereal, for example. And the reason we want this is for reference, so just because we want to know the why. So I'm going to go ahead and ask within our Seek bubble here, what is the best cereal? Knowing that our NeuralSeek documentation is what has been scraped in our knowledge base, and it doesn't include any information on cereal types. So I'm expecting a low semantic score, which we can see here, and there's no objective answer to the question on what the best cereal is. That's just the answer that we were expecting. So let me scroll down and we can look at some of these details that the Seek tab offers. It shows a total response time, a semantic match, a semantic analysis, our knowledge-based confidence coverage scores, as well as our response time, and then our knowledge base results. And a little bit further down, it shows us our knowledge base context, which is showing the links in our documentation exactly where those keywords are being grabbed from in order to generate our answer. We do have a bit of a low semantic score because there is no data in our knowledge base about serial types. It is not completely zero because we have a bit of knowledge base coverage as well, just due to it recognizing some of the letters in the question. But ultimately, there's no source documentation for the large language model to provide us with an answer. And our semantic match is really saying how well did we answer this question and did it match our source documentation? Effectively, this answer is a hallucination because I know that we do not have the coverage or the confidence from our knowledge base to answer this question. So we're going to go over editing our response a little bit later, but just for reference so we can see what a good response with higher confidence is, and let's compare those scores. I'm going to go ahead and seek a question that I know is in our knowledge base. So what is NeuralSeek's seek feature? We have quite a bit of documentation around this subject, so I would expect a reasonably high confidence score. Great, so we have our generated answer here. I'm going to scroll down and look at some of these details. So we have a semantic match of 60%, a knowledge base confidence of 40%, and some coverage of 72%. So I would expect this to have a reasonably high confidence score. Anything over 10 to 20% we would consider a reasonable score. It's hard to get 100% semantic match score as well, just due to variance in language generation, but we have a very respectable semantic match score here with 60%. And then we have some good knowledge base coverage and confidence as well. Scrolling down, we can see directly in our documentation where that answer was retrieved from. Up here, we offer a unique feature of answer provenance, which you can turn on and off, and that's what enables this color coding within the answer. And each color directly links to places in the documentation, a different source of our documentation that answer is being generated from. Our top document that we brought back is showing us, it also shows us our highlighting here, coming from our main features page. This highlighting allows us to trust our answers a little bit more, knowing exactly where it's coming from in our source documentation. So that's a pretty good answer. Following our lab guide, next we're just going to ask a bit of a more nuanced question. So one that we get is, why should I use NeuralSeek with a knowledge base instead of just ChatGPT? To save us a bit of time, I'm just going to copy this question. I'm going to reset my session terms as well, and then just go ahead and click see. So you can see a little bit of different highlighting here. Its highlighting is covering some single words in multiple colors, meaning that this response is relying on keywords and sort of reference material. And the lab guide does offer, I know I've just been over each of these different features and details, and the lab guide does offer more of a description into these key insights as well. But just for your knowledge, this answer has many jumps between source articles, which did lower the overall semantic match score. Reading this summary here provides you with some better information on why these scores were calculated. And then, of course, we can scroll down and look in our documentation exactly where it was coming from. Great. So you can choose to offer or ask a few more questions. We have some examples listed in our lab guide. For example, how does NeuralSeek protect private information? I'm going to pause and load up module 2.2 of our learning lab guide, where we'll be exploring caching. All right, so like I said, next we're going to be exploring caching and how NeuralSeek uses it to enhance performance just by speeding up response times and producing some more consistent results. Caching also reduces computational costs during operation, so it's a really great feature to be able to utilize here. So we're going to start by navigating to our Curate screen, which is right here next to our Seek tab. And first thing we're going to do is look at our inaccurate example answer. The curate gives a great high-level overview of what is going on with each of your intents. Right here, I can see our FAQ serial. And this intent was created after I seeked an answer. The question I had was, what is the best serial? And what happens is over here in the Curate tab, it auto-generates some example questions, different phrasings of how the same question might be asked within Seek. And it also provides you with the generated answer here. And then it shows a chart of the different coverage and confidence scores just for a great high-level overview as well. So on the right side is our generated answer for our intent. And it is possible for NeuralSeek to generate inaccurate answers just due to the content in the knowledge base either being outdated or missing. So we can manually correct this by editing our answers. And edited answers are used to train future generated answers and also used when you curate and export to a virtual agent. So clicking the text box of our answer here, it will pop up our answer to edit. So say I don't like this answer. There's no objective answer to this question on what the best serial is, and it's a matter of personal preference. I want NeuralSeek to know that that is not true and that the best cereal type is Cheerios. Great, so I'm going to type that in and edit, and then I'm going to click Save. We can now see how that answer is marked as edited right here in the bubble next to it. And then so what we're going to do now is make sure that NeuralSeek knows to always serve this edited answer. And we can take a look at this over in the Configure screen. So I'm going to click on that Configure tab. And then down at the bottom, I'm going to click Show Advanced Options. And we offer lots of different accordions with many different configurations, possibilities, ways to tune for your data. What I'm looking for here is intent matching and cache configuration. So I'm going to click that caret to expand this accordion. And here's where we can select how strict we want to be about matching intents. And this is especially helpful if you have edited answers that you want users to hit more. So down below, we have two different scales, our edited answer cache and our normal answer cache. We'll set each of these to 1 in order to prioritize our new edited answer. I'm going to go ahead and move that sliding scale down to 1 for both of them. This is basically saying the edited answer cache, we're going to serve an edited answer when at least this many different edited answers exist for a user question. 1 is what we're setting that to. Our normal answer cache works similarly, so we're going to serve a recent answer if the relevant documentation has not changed, or an edited answer when at least this many different answers exist for a user question. So just as a note that our edited answers do have priority in our normal answer cache as well, followed by our recently generated answers. So keeping these both as 1 is really going to ensure that we're serving that edited answer. So I'm going to go ahead and click Save. We have some version information that we can pop up here. Just for further tracking, I can name this and provide an additional description, but just for our demo purposes, I'm just going to click Save and move on. So let's see how that edited answer gets served. Moving back to our Seek tab, I'm going to re-ask our question, what is the best cereal? There we go. And then I'm going to seek. Great, so notice how our generated output here is our newly edited answer. The best cereal is Cheerios. And there are some details down below that we can explore as well. So we can see first our response time as a little over a second. And right next to it is showing cached, meaning that we have a very short, very quick response time, and it is a cached answer. Our semantic match is 100%. It is hard to get 100% semantic match just due to language variation, but with an edited answer and our cached answer, we'll always get that 100% semantic match. And our semantic analysis shows us that this is our curated answer, and we are confident and there is coverage in it because, of course, we manually edited our answer here. And down below, we can see that our trained answer is coming from our FAQ serial intent, showing our answer. Great, so edited answers are retained until they're updated or deleted. So even if your source documentation changes, use caution when using edited answers just to be sure that they contain that relevant information. So that is editing and caching. We're going to move on to module 2.3 of our Learning Lab guide, and that's going to walk us through some curated intents. So back on our curate screen, like I said earlier, we have this nice high-level overview of our coverage and our confidence scores for all of our intents, and it allows for an easy review of what's being covered by our knowledge base and what's not. So when you select an intent, many different options become available for us. You can select it by selecting that check mark, or this big check mark up above will select all of our intents for us. So the lab guide explains each option in a little bit more detail. We can edit some categories, download to a CSV and pass off to a subject matter expert, flag, merge, delete. But what we're looking for here is specifically our export and our import abilities in order to bootstrap our virtual agent. So the first thing I'll show you is how to bring our virtual agent intents into NeuralSeek first. So we're going to navigate to our Amazon Lex console. Great. So I'm going to move back and I want to find Amazon Lex and then bots. So on the sidebar, I'm going to click bots, and down below, it shows us all of our available bots that we've created and that we're able to merge within NeuralSeek. So in the bots list, in the main view, we're going to select our desired bot, and then we're going to export. So our bot that we just created was NeuralSeek Learning Lab May 2nd. So I'm going to click on that name to open it up. Oh, I apologize. I'm actually going to select that bot. And then up here in our action, I'm going to select our export button. Yep, that's fine. Our bot version is great. We're going to leave that as our draft version. Our platform is Lex. Our format is JSON. I do not need to add an optional password, so I'm going to go ahead and export that, and it'll download it to our local machine. Yep. All right. So now we're going to navigate back into our NeuralSeek instance, and we're still here on our Curate tab. Up at the top, we can see Import Base AWS Lex v2. I'm going to click that button in the upper right corner, and it's going to open up my File Explorer, which I'm then going to select that new Lex bot that I just downloaded, and I'm going to upload it into NeuralSeek. Okay, so now we have our intents uploaded into NeuralSeek, and what I want to do is get this FAQ serial intent over into our Lex bot. So what we can do is select any of our desired intents, and then do vice versa of what we just did. We're going to export to AWS Lex, and that will download a zip file for us. And then coming back into our Lex bot, we're going to stay within our Lex bot screen. I'm going to deselect, and then we're going to click Actions and then Import. This will prompt us with our similar instructions that we saw earlier. So I'm going to add a new name, Learning Lab. I'm going to name this New Intents. And then in the input file is where I'm going to browse for that Lex zip file. And I'm going to upload that. And that contains our manually curated intents from NeuralSeek. I'm going to leave the password blank as optional. For IAM permissions, I'm going to create a role with basic Amazon Lex permissions. No to our COPA. And then leaving the timeout setting and the advanced settings default as well. I'm going to go ahead and click Import. Boy, One moment. I was too idle on my session, so I am just logging in. Perfect. And I'm gonna, under my recently visit, navigate back to that Amazon Lex. All right, so we're just going to repeat those steps really quick. I'm going to go ahead, action, import. We're going to rename this bot as learning new intents. Open up our file explorer, select that Lex zip file containing our manually curated intents from NeuralSeek. Password, I'm going to leave blank. Create a role with basic Amazon Lex permissions. Say no to our Children's Online Privacy Act, and then leave timeout and advanced settings as default. And then I'm going to go ahead and select import. So this is importing a new bot called Learning Lab New Intents that now contain our curated intents from NeuralSeek. So we can find that imported bot here that we've successfully created. And under our intents, we can see that we now have both our fallback intent, our newly created intent, and then each of these manually curated intents from NeuralSeek with the description curated from NeuralSeek. So we can click the build button to build this bot and then also test with our newly imported intents. This makes bootstrapping your agent with manually curated intents very simple. I'm going to skip this step and just move on to NeuralSeek just to finish up our module 2.3. One more feature I wanted to discuss. Over on the Integrate tab, we do offer Lex v2 logs. So following these steps here, I'm not going to walk through them, but I will discuss them a little bit. We do offer round trip monitoring. So to save us a little bit of time, I'll just explain that in this tab with these logs instructions, it provides you instructions for implementing round trip monitoring. So when you enable this feature, it helps keep your source data up to date for optimal answer generation. So in curated intents that are imported into our virtual agent, just as we saw, when they are hit, a callback to NeuralSeek occurs, which then monitors those curated intents for outdated information. And it alerts the user of necessary updates based on changes to relevant documentation in the connected knowledge base. So this is another unique feature that NeuralSeek offers, and we have these step-by-step instructions here for your information as well. But I am going to move on to module 2.4. And finally, within this module 2, we're going to look at intent categorization and PII handling, a few more unique features of NeuralSeek. So users are able to create categories using natural language descriptions to control how intents and user questions can be categorized. We saw that within our home journey on that data screen, but we skipped over it, and we can re-access those features here within our Configure tab. So I'm going to click on Configure, and then I'm looking for the accordion that shows intent categorization section. So I'm going to expand that, and it brings up this nice chart for us to use. So to simply add a new row, we're going to click this light bulb icon to add a new row. And then we're going to add a new category just using our natural language. So our category name here is going to be virtual agents. And then we can also add a URL link for fallback. And the one that I'm going to select is within our lab guide. And it is just a link to a section in our documentation about virtual agents. And then we're going to describe our category just with natural language. So I'm going to say how virtual agents that are supported by NeuralSeek. That is the description of our virtual agents category. We can optionally set a minimum confidence message and also a percentage, but I'm going to skip those steps because they are fine as is. Down below, I'm going to click Save. And of course, like I said, we're going to skip our version information and just go ahead and click Save again. So now when we navigate back to our Seek tab, in here is where we can go ahead and ask a question that will generate an answer with our new intent. So the question that I'm going to ask is, what virtual agents are supported by NeuralSeek? I needed to ask this question first within Seek in order to generate that intent over in our Curate page. So that's what we're going to go look at. So NeuralSeek supports several virtual agents. That's a great answer. So within Curate, we now have that new intent, virtual agents intent that are supported by NeuralSeek. So notice how there's a number 1 under the category section. And when I highlight over it, it's showing that virtual agents category that this new intent falls under. When I click on it, we're able to edit our category. So if I had multiple here, I can edit certain intents that I would like under other categories. But since we have this new virtual agents category, I'm going to leave that as is. And same with if I wanted the FAQ serial intent under that virtual agents category because I found the information relevant, I can definitely go and edit and change that as well. Okay, great. So our last unique feature that we'll cover within Module 2 is PII handling, which is important for maintaining a secure environment and still providing accurate responses. So since the example question that we're going to be using here following the lab guide is not in our knowledge base, we're going to do a little easy workaround back on the Configure tab to get a generated answer. So on the Configure screen, I'm going to search for answer engineering and preferences. Perfect. So forcing answers from the knowledge base, we're going to leave that as false. I just wanted to double check that it was not set to true. No need to save our responses here. So back under our Seek tab, let's go ahead and ask that question. Oh, I apologize. We need to set our personal identification. So at the very bottom, we're going to select personal identifiable information handling. Great. And this is where we can go ahead and add some pre-LLM filters or LLM-based filters. Let me pull up our lab guide. All right. So our LLM-based filters, I'm going to use an example sentence and then also identify the PII element within that example sentence that I would like to choose. Up here, default is mask. You can either choose no action when PII is detected, to flag it, to hide it, to delete it, or to mask it. So we're going to leave it as mask. These are all the different PII detectors that we offer, such as names, credit card information, addresses, zip codes, passwords. You can choose to enable and disable, as well as our try out button allows you to import an example sentence containing PII and test what these different detectors do. So I'm going to add a new row here. And my example sentence is going to be pulled from our Learning Lab guide as I went to college at JMU. And the PII element in this sentence that I would like to detect is our college name. So I'm going to save that as JMU. So I'm going to go ahead and save our new set our LLM-based filter. And then back within our Seek tab is where we're going to ask that question and see that PII detected within our Curate screen and our new intent. So I'm going to ask what colleges are in Virginia and click Seek. All right, so our answer is a little bit vague, and back here within our Curate screen, we can see our new intent created about other colleges. And then so our little screen icon right here next to our newly created intent is showing that this intent has PII in it, and our locations are masked as we set in our PII filter on the configure tab. So what colleges those are in, that is masked with an icon showing that this question has PII in it. And our answer as well has that information masked saying that this answer was formed with a question with PII in it as well. So we can further expand our PII filters and continue asking similar questions just to show how that PII is masked in those newly generated intents within Curate. But to save us a little bit of time here, I'm going to move on to module 3.1, which will be our Maestro tab. So I'm going to load up our lab guide to module 3. So this is the final feature that we'll be exploring today, and it's really exciting because it has a lot of different capabilities, ranging from very simple capabilities to very complex model prompting. Then this is essentially a large playground for that. We'll walk through an initial tour of Maestro and learn how to effectively configure different nodes, modify natural language prompts to the large language model, and be able to generate content within Maestro's unique editors. So I'm going to load up the Maestro screen, and this is our first option that we have available to us. There are many different example templates that we're able to work with, as well as user templates that we can build from scratch and save for future use. So we offer 2 editors within Maestro, the visual editor and then our NeuralSeek template language editor. I'm going to start with our visual editor as it's the easiest way to navigate Maestro. So in the visual editor, different nodes are connected horizontally, which we call chains, as well as vertically. And so nodes are executed starting in the upper left corner. And as the execution runs for each vertical level, any chain existing at that level will be evaluated, and then it continues downwards. So on our sidebar here is where we offer all of our different nodes. So under our get data, we have many different options for getting that data to the LLM. Text prompts, knowledge-based documentation, keyword searches, website text, Google Drive connectors, and we can also upload documents such as PDFs, different files. And then our generating data, we'll be working with this send to LLM as well. But note that there are many different ways to extract data, connect to different databases, RAG tools, ways to modify our data as well. So lots of possibilities within Maestro. The first tour I want to walk you through, though, is we're going to start with our get data side. And our first node we want to populate is our website text node. Just by pointing and clicking at it, it populates that node right here in our visual editor for us. And I can also point and click on that node, and it will pop up a parameters box on the side where I can do a little bit more editing. So our website text, it needs a website to scrape and then return the text back for us. So the website that I'm going to use for this example is neuralseek.com. So I'm just going to paste that URL right into there, and it'll populate inside our node. So on the sidebar menu, again, I'm going to navigate under Generate Data and then Send to LLM. I can either use the text prompt or the Send to LLM prompt to use natural language to prompt our LLM with what I want it to do. All of these nodes, once you click them and drag them, they are movable and chainable. So this is our vertical chain, but I want to drag this over here to the right to connect a horizontal chain. And since I clicked on the Send to LLM node, our little parameters box popped up here, and this is where I'm going to provide my natural language prompt for what I want our large language model to do. In this example, I want us to create a bulleted list from the major topics of the documentation below. So I'm just going to input that in there, and then I'm going to close. And then on the sidebar menu, what I want to do is add one more send to LLM mode. And this is going to send all of our previous content to the LLM, including what's going on in the chain. So like I said, it'll start with website text, chain over to this send to LLM node, and then finally hit this final send to LLM node here. On this second node, I do want to add an additional prompt. So our first prompt is telling us to create a bulleted list from our website documentation. And our second prompt here is we want the LLM to create a LinkedIn post based on our bulleted list, based on our website text, and using lots of hashtags. All right, now we've built our flow here and we just need to evaluate it. And we'll see the output generated right here below. So I'm going to click the blue evaluate button to run our flow. And we'll notice how content immediately starts generating right below. And this is our LinkedIn post created from our bulleted list of major topics from our provided website. And it used lots of hashtags as prompted. This little button in the top right corner is our debugger. And opening up this, I can walk through step by step exactly what was happening with the LLM as our flow is being run. So looking at our first step, which was our website text step, this was our URL that we provided, and this was all the text that was scraped and brought back. Right below that is our LLM chain, and we can see that it was chained because we have that little chaining icon indicator. Our prompt that we provided was to create that bulleted list. So we can see that output here. Even though that output of that bulleted list is not shown as our final output, this is where I can go and inspect exactly what list was created during that step. And then our final step, step 3, this does show our final output. It shows our prompt, creating that LinkedIn post using lots of hashtags, and then this was the output that we received. Great. So you are able to save templates by clicking the save icon here, and you can provide it with a template name and a description. Those can later be accessed from our load template, clicking on user templates. You're also able to convert to a Microsoft Word document or download as a CSV file if that's what your output is looking for. And you can also download the Open API spec. So that's this button right here next to the save, generate an Open API spec. So this will download the flow along with all the required parameters, and you're able to easily import it into tools such as your virtual agent just by clicking that button down there at the bottom. All right, so I'm going to click clear, and we're going to walk through one more example template within NeuralSeek. So like I said before, this was the first screen that popped up when I click on Maestro, and I want to select my example template. And like I said, we offer many different kinds, from custom rags that can be very complex with the flow, as seen here. Or we have more simpler templates, like writing a prospecting email or writing a memo to staff. So that's the one that I'm going to click. And it automatically pops up our flow as needed. These are, again, chainable, movable, adjustable. I can add more nodes on top of our current. It is just an example template, but I like the 3 that we're working with here. So our first box is a text box, which is just using natural language to prompt the large language model. This one automatically comes in with write a memo to staff discussing the following capabilities. And that is linked to a get data knowledge base connection node. So our KB search here allows us to use keywords to run a query directly against our knowledge base. This one is pre-populated with Cognos Analytics, but knowing the documentation within our knowledge base, I'm going to change that to filtering because I want to write a memo to our staff discussing our features of filtering within NeuralSeek. We're able to set a knowledge base filter, a passage size, and a score range as well, but I'm fine with the default settings. So I'm just going to close that node since I'm done editing it. And then finally, we have our send to LLM node, which if it's unprompted or not pre-printed with a prompt to the LLM, then it will just send all of our previous content to large language model and use that prompt to write that memo to the staff. So I'm going to go ahead and click evaluate on this very simple Maestro flow. And down below, we can see the text beginning to generate. Great. So right here below, we have our memo to our staff and it provides some templates, which I can easily modify if I download as a Word document and send, or even copy and paste into an email, whichever way I communicate with my staff here. And it's discussing these following capabilities, focusing on filtering documentation, different answer variations that we can use with our filtering feature. So it ran that search, finding that keyword, and then generating that memo discussing that different capability. So I can look at the debug spec again, and we can walk through step by step. So step 1 was our text node, which is just showing our prompt to write that memo to our staff. Our second step was that KB documentation search. So our query here is filtering was the keyword that we used. It has a set snippet size and score range that I left as default. And then this is the information and text that it returned about filtering, which is where it found those instances of that keyword within our documentation. And then step 3 is our send to LLM node. So we didn't add an additional prompt because we just wanted all of that content to be sent to the large language model. But down below, it shows us, our requested output tokens, our input tokens, and then that memo to the staff. Let's say I think that this is a bit too long. What I can do here is edit, and we're going to condense to one paragraph. And we're going to see how this affects our new output when I do prepend a prompt to the large language model. So I'm going to go ahead and click evaluate one more time. All right, and we can see here that our staff would like to bring your attention to various capabilities. Looks like we had a So of course, this is what is very beneficial about this bug inspector. So we had a little error message pop up, and what we can do is come back here with our Explore inspector and see why and where that hit. So looking here, our text, that one was fine. That's our memo to our text. It looks like our error was coming up from our knowledge-based connection step. So we do have our filtering, but it didn't pull the documentation that we were quite looking for. So this is where I know we might need to make an adjustment to our keyword, possibly an adjustment to our documentation, making sure that we do have that keyword in there for it to be able to pull. And then how that affected our last step 3, of course. So if you're getting not an ideal output or looking to change, or even a possible error that was thrown just like that, using this Explore inspector and walking through step by step each variable really helps to minimize any sort of confusion or disparities on where that flow was going wrong. So I'm going to go ahead and close that. So a useful tip, if you want to continue to play around with this feature, I am noticing the time here, is to grab URLs from Wikipedias, whether they're silly or interesting or relevant to your field of work. Wikipedia is a great text-based platform to be able to utilize when playing around with this Maestro feature here as well. The last thing that I want to point out and talk about within Maestro is down here. So we usually have a semantic answer. Let me re-evaluate. Great. So right here, we show how many generated characters there were, along with a different semantic match score. And I can expand these details here. And this is showing me, similar to what was coming up on the Seek tab, a semantic match and a semantic analysis summary showing, because we were hitting that knowledge base and reaching out and doing a search on our keyword of filtering. So it's giving us, some similar semantic scoring details that I can review as well. Our top score coverage, our source coverage, different key, unattributed key terms and unattributed terms as well. And then if I'm prompting with the LLM without a knowledge-based search and just playing around, sometimes the semantic score will be very low because it's not hitting that documentation. But just another unique feature that we offer there for when you do run a documentation query. All right, so like I said, there's many different ways to output this information and this data, and we can spend an endless amount of time playing around with the Maestro feature, but that does conclude our Learning Lab guide. So I hope you found our session useful and informative, and thank you for your time with me today. Please remember to review the closing steps that are available at the end of our lab guide for information on how to deprovision the instances that we're creating today as to not incur further billing. So I will stop sharing my screen here.